Beneath the cold, dark waters of Norway's fjords, where icy currents flow silently above ancient rock and the seafloor plunges hundreds of meters below the surface, engineers achieved something few believed was possible. They carved a permanent road tunnel deeper beneath the ocean than any other on Earth, cutting through solid bedrock under crushing pressure, total darkness, and constant geological uncertainty. This was not a bridge suspended over water. This was not a ferry crossing battling storms. This was a road driven directly through the earth, far below the sea. This is the story of how Norway built the deepest undersea road tunnel in the world, using advanced robotic boring systems to defeat water pressure, unstable geology, and one of the harshest marine environments on the planet. A country shaped by water, Norway's geography is both breathtaking and unforgiving. Its coastline stretches over 100,000 kilometers, fragmented by deep fjords carved by glaciers during the last ice age. These fjords are not shallow inlets. Many descend hundreds of meters below sea level, forming underwater valleys steeper than most mountains above ground. For generations, ferries were the only way to cross these massive water barriers. Entire communities depended on schedules dictated by weather, waves, and winter storms. When seas were rough, life slowed. When ferries stopped, regions were cut off. To unify the country, Norway needed permanent connections. But bridges were impossible across fjords this deep. The only option left was to go underneath the sea itself. The ambition, a road below the ocean. Norway's solution took shape as part of a long-term national plan: create a ferry-free coastal highway connecting the country from north to south without interruption. At the center of this vision stands the Rogfast Tunnel, the most ambitious undersea road tunnel ever attempted. When completed, it will descend to more than 390 meters below sea level, making it the deepest undersea road tunnel on Earth. At such depths, the risks multiply. Water pressure increases dramatically. Rock stress intensifies. A single crack could allow seawater to burst through the tunnel walls with catastrophic force. At this depth, engineering tolerances shrink to millimeters, and failure is not an option. Understanding the seabed before digging. Before excavation began, Norway spent years studying what lay beneath the fjord. Geologists and engineers deployed seismic reflection surveys, sonar mapping from research vessels, deep core drilling rigs, geological modeling software. Boreholes were drilled from both land and offshore platforms, extracting rock samples from hundreds of meters below the seabed. These samples revealed layers of granite, gneiss, and fractured zones shaped by tectonic forces and ancient glaciers. Every fault line was mapped, every weak zone identified. The tunnel alignment was adjusted repeatedly to avoid unstable formations. In undersea tunneling, planning is not preparation, it is survival. The machines that made it possible. To dig at such depths, Norway relied on advanced tunnel boring machines, supported by robotic systems and real-time digital monitoring. These machines were massive, weighing thousands of tons, yet precise enough to respond instantly to changes in rock hardness and stress. Each tunnel boring machine was equipped with rotating cutter heads embedded with hardened steel discs, robotic steering systems capable of micro-adjustments, laser-guided navigation, continuous vibration and pressure sensors, automated data transmission to surface control centers. As the cutter head pressed into the rock, sensors constantly measured resistance, temperature, and deformation. If conditions changed, the machine adjusted automatically. The tunnel was not dug blindly. It was felt, monitored, and controlled second by second. Descending beneath the fjord, as excavation progressed, the tunnel slowly descended deeper beneath the seabed. Above the tunnel, hundreds of meters of seawater exerting relentless pressure. Around it, rock compressed by geological forces millions of years old. To prevent water intrusion, engineers reinforced the tunnel continuously using a multi-layer defense system. Steel rock bolts drilled deep into surrounding bedrock. Thick sprayed concrete linings, waterproof membranes, pre-grouting with cement injected ahead of the tunnel face. In fractured zones, engineers sealed the rock before excavation reached it, turning unstable formations into solid, watertight barriers. Every meter forward was a calculated risk, measured, reinforced, and verified. Ventilation and life support below sea level. At depths approaching 400 meters below sea level, ventilation becomes critical. Fresh air cannot simply flow naturally. Exhaust gases accumulate. Smoke from even a minor incident could become deadly. Norway designed one of the most advanced tunnel ventilation systems ever built. It includes massive axial ventilation fans, longitudinal airflow control, emergency smoke extraction zones, redundant power systems, continuous air quality monitoring. Fresh air is forced deep into the tunnel, while polluted air is pulled out through separate channels. In emergencies, airflow can be reversed instantly, guiding smoke away from drivers and toward extraction shafts. The tunnel functions as a controlled environment, an underground ecosystem engineered for human survival, turning a rock cavity into a road. Once excavation was complete, the raw rock tunnel was transformed into a modern roadway. Engineers installed reinforced concrete road decks, advanced drainage systems to capture seepage, fire-resistant wall linings, LED lighting systems designed to reduce driver fatigue, emergency bays, crossovers, and evacuation points. The road itself slopes gradually downward, curves beneath the fjord, then rises again on the opposite side. Drivers descend beneath the ocean without ever seeing it, unaware of the immense forces surrounding them. Above their heads, hundreds of meters of seawater. Between them and disaster engineering precision. The moment of breakthrough. When excavation teams finally broke through from opposite ends of the tunnel, the moment marked years of planning brought into perfect alignment. The tunnel sections met within centimeters. No flood, no collapse, no structural failure, only silence and solid rock opened by human design. Norway had crossed a fjord that nature made uncrossable. Why this tunnel matters? The deepest undersea road tunnel is not just a transportation project. It eliminates ferry dependence, reduces travel times by hours, strengthens national logistics, enables year-round connectivity regardless of weather, demonstrates global leadership in undersea engineering. Norway's expertise in undersea tunneling is now exported worldwide, influencing projects across Europe and Asia. What began as a geographic limitation became a technological advantage. Engineering at the edge of possibility. Digging beneath the ocean is not about speed, it is about patience, precision, and respect for forces stronger than steel. Every meter beneath the fjord represents a negotiation between human ambition and the Earth itself, between pressure and reinforcement, between risk and control. In this tunnel, engineering held firm. So now you've learned how Norway dug the deepest undersea road tunnel on Earth, carving a permanent road beneath hundreds of meters of seawater using advanced robotic boring systems and uncompromising precision. Would you dare to drive through a road buried deep beneath the ocean? Let me know your thoughts. And join me for the next story of human engineering that reshaped the world.